Here we go. I'm going to go ahead and bring up our notes here. And we're going to go over these problems, but I need you to give me the necessary information. I will tell you that given your ability mathematically, it's relatively or pretty close to, I won't say impossible, but incredibly difficult to solve these problems without drawing a diagram. So most of you didn't actually get full credit for that assignment because you didn't take the time to actually try and draw a diagram. This is a whole chapter focused on geometry. You have to take the time to try and draw pictures. So from now on, my expectation is if there is a diagram that's being analyzed, you better draw it. Okay? And as a result, and this is kind of what I expected, mind you, I'm giving you a homework assignment this weekend that's a packet that'll require lots of drawing. Okay? So it's very important that you do that. So, and I'll show you why today. All right, first things first, number 16. Okay? 8-2, number 16. This problem in particular, they give you 4 things that you need to know. They give you 2 already, and they want you to find 2. So what is the list of things that they give you? Okay, Caitlin. Oh, hang on a minute. I'm sorry, not 16. Thank you. You were reading the correct one. I was thinking 18. Thank you. 18, would you please? Okay, so the length of the rectangle is 14 inches. We do not know width. We do not know area. But we do know perimeter, and that is what? 34 inches. Okay, so the first thing you have to do is you have to draw a rectangle. This is what I would have expected of you. Okay, so you draw the rectangle, and on this rectangle, you put what you know. Okay, I know that the length of this rectangle is 14 inches. Okay, and why it's important for you to draw the picture is what they don't tell you is that 14 inches counts twice because there are 2 lengths to this diagram. That's important. You cannot solve this problem without seeing that. Okay? So, and we now know that there are 2 things we don't know, the width, but they have to be exactly the same. So I'll call it W and W. Now the other piece of information, the 34 inches, is to tell you that if you add the lengths and the widths, you get 34. How much of that 34 do I already know just with the 2 14s? How much, Gabby? I know 28, right? 28 inches because I have 14 plus 14. So of the perimeter, I have 28 inches so far. How much do I have to add to that to get to 34? Lexi, very good, 6. So I need 6 more inches to get to that 34-inch perimeter. Okay, that 6 inches is what's left. Can W equal 6? It can't, because then this W over here would have to equal 0. But they're the same measurement. All right, so what do? Savannah?
You divide it by 2.
I divide that 6 in 2 so that I have equal portions on both sides. So this is 3 inches, and this is 3 inches. So when I add 3, 3, 14, and 14, I get 34. So the width must be 3 inches. Okay, so I found one of the things they wanted me to find. How do I find the area now that I know width? Gabby? 14 times 3. Very good. Which would be 42. Okay? So then I take 3 inches times 14 inches, and that gives me 42 inches. And that would be my area, so they're inches squared. Okay? So you have to draw diagrams. The reason, and this is not because I'm being a stickler about it, it's because when you get to high school, okay, you get to algebra, you get to geometry, you get to chemistry, you get to physics, and even biology, diagrams become incredibly important. Labeling diagrams, identifying key pieces of information, etc. When I was teaching physics, it was impossible for students to solve the problems without drawing diagrams. Okay? Same thing in chemistry sometimes. So that's why we want to practice it early. It takes 21 times consecutively to gain a habit, and then you have to do it consecutively in order for it to stick. Okay? In order for you to get in the habit of drawing effective diagrams, you'd have to do it 21 times consecutively. Well, that's probably not going to happen. So we need to practice it at least as much as possible so that you're in the habit of doing it when you get to high school. Okay? All right, next one, number 20. 8-2, number 20. Okay, what are we going to do here? What do they give me? Caitlin. All right, what is the length? 7 feet. Okay, what else do they give me? They give me the area. What does that equal? 18.2 feet squared. Okay, what else do they give me? We don't know width. We don't know perimeter. Okay, first thing I'm going to do, this is a rectangle, I take it? Yeah. Okay, so I'm going to draw a rectangle. That is definitely not. Alrighty, that's a rectangle. Alright, I do know that the length is 7 feet. So I know the top is 7 feet. I know the area, so that inside portion I know the area is equal to what again, Caitlin? 18.2 feet squared. All right, I will tell you that of all the problems in your homework, this was the hardest. Okay? The first thing that I would do in solving this problem is I would look at what they give me. They give me length and they give me area. In order to find the width, which is what I need to find perimeter, to find that width, I have to look at the area formula. Does anyone recall off the top of their head what the area formula is for a rectangle? Elizabeth Lixon? Oh, what was your thing you were going to say? Oh, hang on a minute. I'm going to get there. Yes, you're correct. I'm already going to tell you you're correct. Nice job. But start with this. What is the formula for area? Burglar. Okay. It was 19.2?
Yeah, that's the paper. That's not for what you're solving. Not what you're solving.
Hang on a minute. Well, let's see if we come up with that. Give me just a second. I'm guessing that the perimeter is 19.2. All right, we'll get there. Base times height. They use slightly different terminology here. So it'd be length times width. Man, I got all kinds of messages coming up. All right, so we got length times width. So I'm going to plug in what I know. I know that 18.2 equals 7 times W, which is 7W. How do I get the W by itself? Isabella?
You do 7W times 7.
Times? Oh, thank you. Now, can I do it to just one side, Isabella? Oh, I absolutely have to do it to the other. It's a golden rule of mathematics.
Oh, it is? Or is it?
What I do to one side, I must do to the other. It's like in fractions. What I do to the top, I must do to the bottom. Oh, glorious. Glorious. Okay? So, no, absolutely not. All right. 18.2 divided by 7, which is what Lixon was getting at. 18.2 divided by 7 gives me what width? Gives me what width? Come on, 18.2 divided by 7. Yes, it's like what? 2 point what? 2.6. 2.6. I just found one of my things. Now, I take that 2.6 and I plug it in here and here. That's again, the diagram is important. So it's 2.6 goes here, 2.6 goes here, and now I add up all the sides. 7 plus 2.6 plus 7 plus 2.6. Okay, so the perimeter is going to equal 7 plus 7 plus 2.6 plus 2.6. Okay, I'm going to do the math in my head here. I'm not going to use a calculator. 7 plus 7 is 14, plus 2.6 and 2.6 is 5.2. 14 plus 5.2 is 19.2 feet. So that's the perimeter. Okay? So that's how you would have worked this. So they give you the length, they give you the area to find the width. You've got to kind of work with what you know. To find the perimeter, once you find the width, you add it all up. Okay? So that's how 18 and 20 were supposed to go. Today is actually a continuation. Your assignment is a continuation of yesterday's work. Okay, I already did the notes for tonight's assignment. It's dealing with triangles. I want to briefly review it so that you have about 15 minutes in class to work on your assignment and ask good questions. So, before I start, however, Gretchen, what is your question? Yes. For 20? 19.2 and 2.6. All right. Say I have a triangle. Okay, I have a triangle, and this triangle has a height that is defined by the following. Okay, let me go ahead and This is going to be kind of tough.
Yeah, especially Parker in here.
Okay, the height of this triangle is going to be 7.3 meters. The base is going to be 4.6 meters. The hypotenuse over here is going to be 9.7 meters. Okay, so if this is my triangle measurements, okay, how do I find the triangles? Oh, by the way, I need to do one more here. This inside diagonal part is going to be 8 meters. Okay, so if I have all this information. Okay, I want to find the following. I want to find the area, and I want to find the perimeter of this triangle. Anna, what do I do to find the area?
7.3 times 4.6.
Okay, you're on the right track. I do want to take the base, which is 4.6, and multiply it by the height. But if I were doing just base times height, that would be for a rectangle. What do I have to do with the formula to make it represent a triangle? Gabby.
You have to divide it by 2.
I have to divide the whole thing by 2. I have to take half of it. Okay, so let's start with that. I'm going to work with area up in the upper right-hand corner. Area equals 1/2 times the base times the height. Okay, so I'm going to take 1/2, which is 0.5, and I'm going to times that by the base, which is what number? What's the base of my triangle? Gabby? 4.6. And I'm going to multiply that by the height of my triangle, which is, Anna? 7.3. I'm going to multiply those 3 numbers. That's it. So what do I end up with? Multiply these 3 numbers. Absolutely. Yep. On triangles, you always do the 0.5. Yes? 16 point, let's just say 8. Okay, and what are going to be my units here? It would be units squared if I didn't give you units, but what unit do I give you, Parker? No, you got this, Parker. Meters. So it would be meters. Nice job. Meters squared.
Couldn't have done without Parker.
Something like that. All right, how about perimeter? How do I do perimeter here? Perimeter, remember, is just adding up all the sides. It's pretty simple. Gabby?
9.7 plus 4.6 plus 8.
Yeah, 9.7 plus 4.6 plus 8. Gabby, I'm going to ask you a question, though. Why don't I add the 7.3? It's the height. It's not actually a line that's part of the triangle. Very good. You're going to have several problems in your homework where the height is not necessarily going to be the side of your triangle. Gretchen?
What would be
9.7
9.7?
is. 9.7 is this length right here. That's 9.7 meters long.
So the height will always be the dotted line.
Not necessarily. The height is from the top of the triangle to the bottom of the triangle.
But that's from the top.
No, it's not. It's slanted. It does go from the top to the bottom, but it's not a straight down. For instance, when I measure a roller coaster, I don't measure the roller coaster from here. If I want to know how tall the roller coaster is, I go from directly under the roller coaster to the top of point of it, right? Right? Otherwise, if I see a roller coaster 18 miles away, I could say from where I am to there is 18 miles. Is it 18 miles high?
No.
There's nothing on Earth that's 18 miles high. So, no, actually there isn't. There isn't a single mountain or anything on Earth that is from sea level to 18 miles high.
Airplane.
They're not touching
Sun.
the ground.
Sun's more than 8.
I'm
That's
not
not
tall.
tall.
That's not on Earth.
Guys. All right, so here's what I'm getting at. Height is always measured vertically from the very bottom of an object to the very top of the object in a straight up vertical line. So while Gretchen is correct in saying that that goes from top to bottom, it's slanted. Height is not going to be slanted. Okay? A better way of saying this, is that it's the shortest distance between the top and bottom. Okay? Height is always defined as the shortest distance between top and bottom. So the sides that make up the perimeter are going to be the sides of the triangle there. The height is and sometimes can be a side, but oftentimes it's not. So when I add those three numbers, what do I get as the perimeter? Gretchen? 22.3 did I hear you correctly? Okay, and what would be the units for perimeter? Just be what Parker said that first time around. Meters.
Wait, why didn't we use the 7.3?
Is the 7.3, Mackenzie, a side of the triangle? It's not. So it can't be part of the perimeter.